Unit 9.6 Polymorphism. All right, let's start off by finding out what this actually means. So we're going to do a definition. I have a quick Google search to show. And the Google search is simply polymorphism in Java. And here we have it. AI generated, which is nice. Let's check this out. Polymorphism in Java is a key concept of object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. So let's kind of back up on that for a second before we go any further. A lot of different types of mail, all can be treated as just mail. Let that one sink in. See, the concept here is because we have this nice object-oriented design for the API, all these guys can be treated as just simply mail. So you may say, well, what does that have to do with anything? Let me remind you. You remember I'm asking this question, why didn't we just make it like this? Why did we make it like that? Like, what's the purpose of signing a box to a priority mail? Why? Because polymorphism. See, if I treat this particular mail as a priority mail, it doesn't matter if it's a box or an envelope. It still is a priority mail. How so? Check the API. Look on the right side, the tree on the right over here. Both of these have a common type. They're both priority mails. This is a priority mail, and this is a priority mail. Very powerful. Polymorphism. Let's read a little bit more. It says this means that you can use a single reference variable to refer to objects of different classes, and the appropriate method will be called based on the actual object type at runtime. So we have the two things going on here. Method overloading. This occurs when multiple methods with the same name but different parameters, either in number or type, exist within the same class. Let's back up and check that. I know we gotta put it all together now. See, overloaded. Name is the same, but the type in number or kind. You see, this has none, this has one. So it's properly overloaded. And then the computer determines the method to call based on the method signature at compile time. So based on which one we call, that's what's going to run. And then we have polymorphism for runtime, which is the overriding. This occurs when a subclass provides a specific implementation of a method that is already defined in the superclass. Let's take a look at that. Postage. Postage. See? Boom. This is the parent mail. This is the child. And let me go for a child of regular mail, envelope, override. So once we do that, then polymorphism is in full effect. The method to be called is decided at runtime. So there is an attachment. Let me scroll down so that Google gave us a nice example using the Gemini AI. Here's a class called animal. Now you may wonder, what's its parent? Object. When you don't see an extends, it extends object automatically. All right, this is the kind of question the AP exam will have. So if you have an animal, it makes a sound. Now, this animal makes a sound. The dog, who extends animal, because a dog is an animal, it too makes a sound. A cat also makes a sound. So now we have three, well, you could say four, including objects, classes in this API. Object, animal, dog, and cat. All of them are making a sound. So this is one way you can figure out if a method is polymorphic. It's everywhere. If you see the method everywhere, it's polymorphic. It's overridden. This is a full overriding. Okay? A dog doesn't make a sound similar to an animal. So nothing about super dot make sound is in here. A cat doesn't make any sound like an animal. So no super dot make sound is in here. Fully overridden. That means when the cat makes a sound, it says meow. When the dog makes a sound, it says woof. And when an animal makes a sound, it makes a generic sound. Watch this. Polymorphism. See? When we make a dog is an animal. A cat is an animal. So I can ask each animal to make a sound. Well, you'll say, well, which sound would it make since I'm using animal? Would it do the generic sound? No. It's going to do what is called dynamic method binding. What it does is it checks to see what type of animal it is, instance of, that's why I showed you that. Instance of, if it's an instance of a dog, attach the woof sound, this one. If it's an instance of a cat, attach the meow sound. So now we could make an array of animals, put all the animals in and write a loop, and it gets noisy. That's how a video game is actually made. So if I had a lot of characters and they're all making their own sound or doing their own actions, whatever they're doing, I just write a loop. As long as that method is polymorphic, how do you know? It's everywhere. You can see it here, here, here. If it's missing in one of the classes below in the API, it probably does it like the parent. So even if it's not there, it's still there. So that would mean then a polymorphic method is one that you can see it's everywhere. You're going to see it. The same signature. Okay, not overloaded now, overridden. Everybody has it. Why is that important for us? Here we go. Let's go back to the top. Forced behavior. Everybody does it. So, calculate postage is polymorphic. Everywhere. You look at it, you go, where is it here? It uses its parents. So it does it just like this. Come over here, it's here. Come over here, it's here. Come over here, it's here. Now you will look at it and say, wait, where is it? Where is it? It's not here. Yes, it is. It behaves just like its parent. You're just like your mom, or you're just like your dad. You do your postage just like your mom. Right here. Let's go over here. It is here. Calculate postage is just like the sound. Now, here's the power of polymorphism. See, if I were to create these objects and I put them all the way to the top, they're all males. Everybody's a male. Then you know what I can do? I can say, hey, regular, calculate your postage for me. I can say, hey, calculate your postage for me. I can say, hey, M, calculate your postage for me. And I can say, hey, M2, calculate your postage for me. Very powerful. See, I don't have to create a regular envelope and then a priority and then so on. I don't even have to care what I call them. Let's call them M's. Like let's say this was M1. This was M2. This was M3. And this was M4. I could just go M1. I'm doing this because I wanted to think of an array. M2. I should use 0. M3 and M4. Doesn't matter. They're all males. And one thing we know for a fact is that all males calculate postage. All of them. Forced. Must do it. So, I don't have to worry about what type of male it is. I just say calculate your postage. And based on the male, it would do the right thing. So let's check that. I'm going to make this, I'm going to come down in order. So let's make this like 4.0. And then we're going to do the from address and to address. And I'm going to go with 3.0. And I'm going to go with 2.0. And then I'm going to go with 1.0. So all I did just now is I just went 4, 3, 2, 1, 4 males. Print them. So polymorphically, I'm calling every single one of these things and asking them to do your calculation for your mail postage. Now you realize that the postage that's happening here is going to attach the right one. So it's an envelope in M1. So it's going to go to envelope and it's going to do the postage for envelope. So you look here, you go, wait a minute. There is no calculate postage here. Yep, that's true. It does it just like its parent. Where is it? This does it just like its parent. Where is it? Regular mail. Send back $1. Let's go to the next one, which is M2. M2 is a priority box. So let's go check priority box. Where's your postage? Right here. It's going to attach the correct postage polymorphically. That's why the Google explanation said at runtime. It does it when you run it. So let's run it. Now we could go ahead and check to see if this is all right, but we know it is. So M1 is $1. We knew that one. What about M2? Let's check that out. That's a priority box, so we got to go checking it out. So it says if the weight is below $1, the postage comes back as $5, but it came back as 15. So it came back as 5 times 3. Let's see if that's correct. Yep. 5 times 3 is 15. Let's go to M3, which is 2 pounds. 2 pounds regular envelope. Let's go to that. A 2 pounds regular envelope. Ooh, nothing's here. Let's see what it does. Regular envelope, gonna do it just like its parent. It's gonna send back $1. And then last but not least, we have a priority box, which is a 1 pound. Let's go to priority box. 1 pound priority box says if it's less than, no, it's going to do 1 times the weight. And the weight is 1, so $5. See? No need for me to worry about what type it is. So if you're wondering, okay, so what's the true way or advantage, the right move for this is an array. See, I could have done this. I could have said, hey, I'm going to make an array of mail. I'm going to call it mails. Okay. And I'm going to inside here. See, I'm not instantiating this. I'm creating an array of mails. I'm going to put M1, M2, M3, and M4. And now I can write a loop. I'm going to write a for each loop for each mail in mails system.out.print ln m.calculate your postage or mail. Powerful. Very powerful. This is doing the same thing as this. So I can then create a whole lot of mails, like in the post office. I could have like millions of mails. And then just run them through that machine and just put the postage on. Now you see, this is the power of polymorphic behavior. I want to point out one thing though. And this is the part that gets some people. Actually, you know what? Let me do this again. I'm going to make a for each loop and I'm going to make an index loop. Mails dot length. Print the mail. Watch this. See the difference? Not mail now. It's going to be mails at position I. Another way. Index loop. This is a for each loop. Another way, we call it enhanced loop. So this enhanced loop, this index loop, and this all the same way. Let's call this the manual way. I did it one at a time. Here I put them all in an array and I wrote a method for it. I shouldn't say a method, I wrote a loop and I did it for each loop, and then I did this one with just indexed. All three doing the same thing. I'm gonna separate them out. Now one thing I want to point out though before we wrap up is this. You see, right now I'm calling a polymorphic method, so it's perfectly fine. Everybody does this. The other one that everybody does is calculate the insurance. Right? I mean, I could have done, instead of calculate postage, I could have said calculate insurance. How do I know that? Well, because if we go back to the top, we force all kids to do these. So it doesn't matter which kid it is, it will do this and this. One thing I want to point out though, which is what I did before. Remember that overloaded method? See that? See, this only pertains to the guys on the right. So only priorities could do that. So let me show you something. This is going to get a little bit tricky. So let's take our time with this one. See, the priority box could calculate the insurance as long as we have some extra insurance, right? So I'm going to try to do that. So let's see. This is a priority box, M4. So they're going to go, hey, M4 dot calculate the total, has insurance, true, right? So let me print this as well. And let's run it. $11.25. M4. Priority box. Let me go ahead now and show one more. Actually, you know what? Let's show one more thing. The cost. Just trying to remember the cost. Can't forget that one. See this calculate total? It too can be done by everybody. Like I could do it here. I don't want just the postage. Calculate the total. And they all have extra insurance. Now obviously, you know, I may have to have some array, or I must have something that feeds this information to me, because some may have extra, some may not, and stuff like that. Okay. So if that's the case, then I could, yeah, maybe this one does not, this one has, you know, false, true. I need some kind of information here. But I'm going to pretend that they all do. See? Boom. That's the beautiful piece. That is the beautiful piece. The concept is this. When you're writing a API, you have to provide a way such that you can have methods that are polymorphic in behavior. Everybody does it. Now this one is at the top, so this one is inherited. So it gets tricky here. It's inherited. These are polymorphic. It puts the right postage on based on which one it is. But this is also checking to see if it actually has extra insurance that I can add on. So it's neatly wrapped up, all of it, done. So that when I get to the main, I don't have to worry. I don't have to wonder if it's possible to call this method. I just call it, and then boom, everything works. Nice and neat. Polymorphism. One more time. See what we do. It is a key concept. We want many classes to be treated as one. Same method being called, but they all do it differently. See all the numbers down there? All different. See? I mean, I'm not going to go through them, but you know, I'm going to pretend that they're all right. Not going to check them, but All of it being done the right way. Putting the right values on immediately. All right, this is section 9.6 polymorphism. That brings us to the end of 9.6.